Okay, from Revit to Rhino. So as we did, I think in the previous videos, they're probably in YouTube, you can just literally draw um, the perimeter of your lines of your project, whatever perimeter it is, again, or if you have it already, I don't know what the shape is. Let's just imagine that's your perimeter, and you can get only the lines exported as DWG, no? So you can, if you have a lot of stuff here, you can just export to another file and have one Revit file only with the lines. So you can basically export this as a CAD drawing as DWG. Now, I'm not sure of the scale of this, so you probably have to be sure that the scale is correct. And here it has to show only the lines of, again, the plan perimeter of your project. I'm going to save it in my desktop. Okay, so now Ryan is not opening because a picky guy. Let me pause this. Okay, so we export as DWG. The first thing you need to do is make sure that the units, so I'm typing, as you know, in the command line, whatever you want to do is always the same, and units, feet, and then feet and inches. Okay, so basically import is the command that you type in the command line, enter hello DWG. It's going to come precisely in whatever scale it is, and in the same exact reference to the 00, which is very important. I wouldn't move these elements around or anything. Okay, so here's how it works. Rhino is a tricky one, but if you use the gumball, which is this guy here, I think it's quite easy, to move using the arrows up, down, etc., and rotate. So that works. Now, how this, you just type the commands here. And the commands do whatever you want to do, whether it's move, extrude, etc., etc. So one thing I would do is select the entire set of curves. Maybe there's a command called join, just to make sure that the lines are joined, and then the command extrude. If you extrude this as a volume, you can already set the height. I'm not sure the height. I don't even know if the scale
is 29 feet.
Yeah, but the lines are not accurate as well.
Yeah.
So let's imagine this is a space.
Okay.
And now the question is, you can obviously work with layers, blah, blah. You can put one, right-clicking, change up your layer and lock it and turn it off and on whenever you want. And the detail you can turn off now because we don't need it. So we have this volume, we have the heights, etc., etc. Where do we create the curves? If you double click on perspective, you need to figure out basically what is the view that is best to draw your lines. No? So it's probably in the front view because you're creating a series of curves in this direction and then connect them through a loft. No? So then I go there, double click on front, and I'm going to say curve the command. Okay, it runs a bit more like modeling clay, so it's definitely, once you get all of it, it's easier than Revit in general. Now, notice how it snaps here. So it snaps to the different points. That's because the snap is on. So you can turn that off for a while so you don't have to be worried about the snapping and create any curves you want. And do just one and enter at the end. If I go back, double click, that's where your curve is.
That's planar right now.
It is planar because I drew it in the front view. So as I was drawing, look what happens in the perspective if I draw a circle.
Because every time I do that in the front view, it's like, I think I'm putting it all planar, and then all of a sudden the one point is like 20 feet in the other direction. And
so here's what happens. You had the snap on, which is you like in AutoCAD, you're being attracted to point. If I create a curve here and I start clicking anywhere that is not attracted to an object, it's everything in the 0, 0 plane. But the second you click here, it says end, Look in the top view where
Oh
it's going.
no.
So that's what's happening, no? So you
Yeah.
want to get rid of that, at least for this curve, and then just that's not going to be attracted. Everything you do, no matter how crazy it is here, it's been done in that plane. Okay, which I kind of like that curve, so I'm going to keep it too. Delete the other one. So you can go back to perspective, and the way you can go about it is just selecting that, pressing Alt and the arrow that you want to copy in that direction on. So you want to copy in the direction of the Y, which is the green. You don't click on the circle, the arrow, and press Alt. And that copies it parallel to the previous. Also, it's a little pain. Once you press, you have the control points. Just don't worry about it and click on the arrow back and make as many curves as you want. And you can delete them. Well, let's have 4 only. Well, now that we know that when you select the curve, the points can be moved because you can select them and move them. The question is, if I move it pressing the green arrow, this is what happens. They're not in parallel planes anymore. So you want to move them using only the blue or the red, or another feature, which is this little pancake or this little grid element, which moves it, constraining the Z and the X, basically the blue and the red at the same time. You can select a bunch of points. Too many, all of them. You can select also those curves, and you can click on this red box or blue box to scale it in one direction or in the other. So as long as you use the blue and red, that means that you're not ever taking this away from that plane. It has to be constrained to that plane. No? You can also delete the control points and make the curve smaller. It doesn't. It's not like Revit that it loses the thing. So you can make the curve slightly different. Anyway, whatever curves you need. And then how does it work? Loft is the command. The way it works, you select the curves in order and one by one, and you select them in the same area, let's say on the front of the curve. You press enter once you're done. There are different options, but you just keep it as it is. And then you can also click up the triangle, say render, so you can see it render, or you can see it shaded. Just turn off the box, and that's the thing that we're doing, right? There are different types. If you want to check them, that slightly changes a bit. Straight sections, a little what you're doing in Revit right now. And uniform, they're just different parameters. You can change other parameters, but anyway, the normal is a good one. And there you have a very complex surface. Now here's the thing. I have a box and I have a surface. What do I do? Well, Rhino is a very good one. You can say trim. Okay. If you press enter, you select your box, not the surface. So again, trim, enter. I need to unlock the box, select the box, which is the cutting object, enter, and say, what do you want to trim? You want to trim this. And that's it. Turn off the thing. And that's exactly a ceiling element that even cuts that little curve element. No? Now, maybe in your case, it's not exactly what you want to do, because maybe your curve has to also consider the walls. So I'm going to go wireframe. I'm going to go to I'm doing Control Tab for the front, and I'm going to bring these guys here, no? Because that's pretty much what you want to do. And I'm obviously exaggerating, but you get the idea. No? Now I could also just make sure this is, or I can even extend, probably extend this better because when you trim it, it's going to be precisely there. Control tab, control tab, control tab to go to the perspective. Press Alt, arrow to copy. Copy. And then we can change each of these, as I said, with the arrows that we are discussing down, further in, delete a couple of these guys, whatever. So each of them is slightly different, whatever it is, like just for you to think about. So it's extremely malleable and easy once you get hold of it. I understand that, you know, if you've been working with Revit, jump into Rhino is like a pain. Okay, so we have those curves. They're again in different planes, but they're parallel to each other. Loft, enter, select bottom, 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 and in order, and it should connect them nicely. I want to shade it here, and then I am going to do the same thing, which is basically trim. Trim, enter, select red box, enter, surface. Oh, can turn it off, and this shape is the one. Now, I think it's complex. Most probably Revit is going to say, not even close, I won't do that. But I will tell you the process of how you actually take it to Revit now in a very easy way. You're going to basically get rid of everything that is not the surface. Okay. You might want to place it in a layer. Right click, change layer, and right click, rename to make sure, and you call it ceiling component. Okay, you turn it off, turn on this one, you get rid of that because you don't need it anymore. And you just make sure that you only have this file, which is the surface. You save it, Control S. Should have saved more times as you were going. Ceiling components, you might want to return to this. And you select the piece that you are happy with. Export, selected, SAT. SAT extension, give it a name, default, go back to Revit, and here's how it goes now. File, new, conceptual mass. This is the only way you can do this. Double click on the only option you have. There's no more options, there's the mass option. It opens a new interface in Revit, which is to create conceptual masses, and insert, import CAD, not DWG, it's actually SATs, and there it is. I'm not sure, hopefully the scale was decent. I think it's way too big, but anyway. There is the monster. You save that SAT file, sorry, this Revit mass file, which is the ceiling mass. Now it's a Revit element. Load it into the project. It's huge, but it shouldn't be. I think there's an issue of the units. I don't know where I did that. But in theory, when you bring that element, it should correspond exactly. Let's see, why is so big? Maybe it's the way I export it. So taking forever because of the, I think, the recording. You need to go to the side view and click here. And now if I guess I did the scale incorrectly in Rhino. That's my guess. Now I will probably have to look at it. But this will come and should come exactly and precisely to this environment. I can send you another kind of video tutorial talking about these issues. So that would be an element right there. That it does not correspond, as you can see, with the scale. And I think this is an issue of when I took it as a DWG. But if I think if you do the scale, and I'll send you some other videos, that it will be precisely corresponding with this element. And how does the conceptual masses work? Now you can actually, on your massing inside, generate roofs or walls or floors. Floors we can't do with these masses, not a solid. But theoretically, we should be able to do a wall. Although it's such a complex one, it's probably going to tell us no way. Let's see if it works. My guess is not going to do it, but I don't know. The idea is that this is the steps that you follow. Maybe the can make the baseball shape. See, so it doesn't do it. Current system, does it do it? If it's a more measured surface, I think you will be able to do it with no problem. And I can send you now another video tutorial, but that's the steps. The step is always to take the line drawing to Rhino, model in Rhino the thing that you want to do, and bring it into Revit as an SAT conceptual mass, and that's the way you convert it through the massing inside options. I could have done a much more easy or relaxed surface. Let me actually stop this one.